Welcome students to lesson 12 of the natural hazards topic. In this lesson you're going to take a military plane into the centre of a tropical storm to find out what it's like there, and to learn about the conditions within a tropical storm, which will help you to understand how they are able to cause so much damage wherever they go. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. Please write 1 to 8. Answer the questions from memory and then mark your answers. Game time. 1. The minimum wind speed is 74 miles an hour. 2. The latitudes are 5 to 15 degrees north and south of the equator. 3. The minimum water temperature is about 27 degrees. 4. Evaporation happens when water warms up and turns to gas, or any liquid. 5. Condensation releases heat. 6. Tropical storms are called cyclones in the Indian Ocean. 7. Hurricane Katrina happened in the Atlantic Ocean. And 8. Tropical storms happen in the late summer and autumn because the ocean and sea takes a long time to warm up to 27 degrees C. Remember, the warmer the water is, the larger and more powerful tropical storms are. Give yourselves a mark out of 8. If you got 7 or above, you've really mastered these ideas. Well done. Any less than that, test yourselves on these questions repeatedly until you've memorized them. To introduce you to the idea of what a tropical storm is like inside, I'm going to read you a story that is inspired by true events to help you understand what someone's experience would be like if a tropical storm was passing overhead. For this online lesson, I have posted the story into the lesson so that you can read it yourself as well. Kate was rushing around her house in a frantic state, packing all she could into watertight boxes and slamming down the shutters. She was terrified she was too late. Why hadn't she prepared sooner? At first, it was a gentle tapping on the walls and roof, but soon the tapping became a roar. The wind howled and the rain poured harder than she believed possible. She could barely see the car sitting outside from her one window without a shutter. There was nothing more that could be done. Hurricane Katrina had arrived. The first hour was intense rain. Sewers outside started overflowing, and she watched as litter and leaves swirled violently outside. Then it got worse. The wind picked up. That's when she heard a creaking from above her, and the first drops of water on her head. But she was inside. As a reflex, she looked up and saw a crack emerging in the ceiling, and suddenly it grew into a hole. Just as she thought the whole roof would be ripped off, the noise calmed and the rain slowed. But Kate understood this too well. She was in the eye of the storm, the brief calm moment that fools people into believing it's over. For 8 minutes she did everything to patch up the ceiling, checking the shutters as she went. Then she waited. She had barely taken position again when the roar returned. The wind and rain, like a tap turning back on, crashed into the house again. She looked out and her car was gone. The trees in the road reduced to shattered stumps. A sudden bang and she climbed under the bed. Her best efforts could not stop what happened next. The roof, tiles, wood, and all were torn from the building. Water poured in, and she knew then it was not a matter of watching the storm pass, but surviving it. This, while it might seem like an over-dramatic story, is in fact the lived experience of many people who go through a tropical storm. In this case, Kate survived, but many are not so lucky. So hopefully this helps you to understand the different parts of the experience. Let's go into more detail. So what are the features of tropical storms? Here's a tropical storm from a satellite view. This is Hurricane Katrina in 2005. You can see some certain key features. There are large rain bands that swirl around towards a central point where there's clear skies. It's huge in size, hundreds of miles across often. Dense clouds towards the centre but thinning out towards the outskirts. So what does this look like if you were to cut this storm in half and look at it like you were looking at a cross-section of the side of a cake. Please write the subtitle, and if you wish to go to the internet and get a diagram, fine, or you can just draw this picture and label it. Here is a tropical storm cross-section, so side view. What are the key features that you need to know about? Well, first of all, size. Tropical storms can be up to 600 kilometers across and 15 kilometers high. They only reach 15 kilometer limits because that's the top edge of the troposphere, where all weather on Earth happens. As you can see, tropical storms are formed of several key parts. First of all, in the very center of the tropical storm is intensely rapidly rising air swirling around a central point. This is the lowest air pressure area around here. This central area is called the eye of the storm, and it's actually calm. There is high air pressure here as the cold wind from the upper atmosphere rushes downwards due to the spinning of the tropical storm pulling it downwards to fill the low air pressure beneath. Around the eye of the storm is the most powerful area of the tropical storm. We call this the eye wall, here and here. You can see it here. This is the area with the lowest air pressure and the most rapidly rising winds. Intense rising winds create an enormous cloud column here, with the heaviest rain and the fastest moving winds, up to 195 or even more miles per hour. The eye itself is often about 45 kilometers wide. Beyond the eye wall are bands of rain clouds, here and here and here, which are also areas of intense low air pressure. They have heavy rain and rapidly traveling winds, though not as powerful as in the eye wall itself. Between the bands of rain are higher air pressure sinking air. Beneath the tropical storm is an area of intense low air pressure, much less air as it's all risen. This is causing air to rush in from all around, which is responsible for the intense wind speeds. This low air pressure has a particular effect on the ocean beneath it. Much like when you suck through a straw in a drink, the low air pressure causes the water of the ocean to actually rise up slightly beneath it. When you suck through a straw, the water rises up through the straw because you've lowered the air pressure within the straw. You've removed air from the straw. Consequently, the water rises to fill that lower air pressure. The same thing happens here. This, combined with the rapid winds, which create enormous waves, leads to something called a storm surge, an area of heightened water, almost like a bulge that follows the storm as it moves. This storm surge can be extremely dangerous when the storm makes landfall, which means when it reaches land, as that risen water area can travel over any sea defences and flood the land. As you can see here, the storm is moving. In the northern hemisphere, it travels in a northwestern direction, and in the southern hemisphere, it travels in a southwest direction. You can also see that the storm itself is rotating, anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. These are the key parts of a tropical storm. If you recall, Kate was first hit by the heavy rain and wind. Then the eye wall hit and the wind intensified further, damaging the roof of her house. The eye then passed over, leading to a moment of calm, before the second part of the eye wall hit, tearing the roof clean off, providing yet more wind and heavy rain. Those further rain bands would have led to even more rain hitting Kate's house and flooding the surrounding area. And that's why you have these different moments when a tropical storm passes overhead. Now, the question that I introduced last lesson was, why do tropical storms spin? It's a very complex question, but I'm going to try and develop your understanding now. Look at this focused part of the global atmospheric circulation model. As you can see, the winds that travel towards the equator do not travel straight towards the equator. They are deflected in certain directions. From the northern hemisphere towards the equator, they're deflected to the right. If you're looking down from the northern hemisphere towards the equator, they're deflected to the right. And if you're looking up from the southern hemisphere towards the equator, they're deflected to the left. Why does this happen? Well, look here. The Earth is widest at the equator here, and it's narrowest at the poles. Because the Earth is spinning, any area nearer the equator has to travel further than any area further from the equator, because the Earth is solid, so everything has to spin at the same time. If you travel further, but you have to go the same distance, then of course you have to travel faster. So why is this important? Well, it means that any wind rushing from the northern hemisphere towards the equator is actually rotating slower than the equator is, because it's further from the equator, and consequently when it travels towards the equator, which is rotating faster, it's actually deflected to the right. It falls behind the equator. Any wind that is closer to the equator and traveling north is actually traveling faster, is rotating faster than the area of the Earth that is further north of the equator. And consequently, because this wind is rotating faster than areas of the Earth up here, it moves ahead. And the exact opposite happens in the southern hemisphere. Wind, surface wind that is traveling away from the equator, is deflected to the left if you're looking from the equator south, because the equator is rotating faster, so it overtakes the area of the south of the equator. By contrast, wind that is moving towards the equator in the southern hemisphere falls behind the equator because it's moving slower, being deflected to the left. The effect of this deflection, which means the change in direction of the wind traveling towards or away from the equator, is that when that wind meets, it meets at an angle from each other. And that causes tropical storms to begin to spin. Remember that that wind is coming together because of an area of low air pressure in the first place. Wind only happens when there is differences in air pressure. A tropical storm, intense rising air, creates an area of low pressure which causes the wind to blow in. And that means that in the northern hemisphere, the tropical storm rotates anti-clockwise, and in the southern hemisphere, due to the direction of deflection, the tropical storm rotates clockwise. I'm now going to show you a brief video which explains this very clearly, visually, using a rotating device to help you understand this better. Before this, look at how the Coriolis effect also makes tropical storms move in a different direction. Tropical storms in the northern hemisphere curve to the right. Why is that? Because since they are traveling faster than areas north of them, they start to overtake, and so they develop this curved motion like that. By contrast, tropical storms in the southern hemisphere bend southwest because they're traveling faster than the areas south of them, so consequently they start to overtake areas south and develop this curving motion. However, you'll notice from the shape of these arrows, they almost never develop a full curve because by the time they pass the tropical lines, the water is too cold for them to continue. So the Coriolis effect, how does it work? As you watch the video that I have linked below, please watch from minutes 2:48 until about 3:48 to understand how and why tropical storms spin, to deepen your understanding of the Coriolis effect. Time to assess learning. I'm going to show you 3 paragraphs with some keywords below and some gaps within them. Use the words to fill in the gaps. Write 1 to 16, put the words in the gaps, and then mark your answers. Game time. Okay, let's go through. Number 1. The Coriolis effect happens because when the Earth rotates, areas close to the equator are moving faster than areas close to the poles. In the northern hemisphere, this causes wind moving north to curve right, east, and wind moving south to curve left, west. This effect does not occur on the equator, so tropical storms cannot form there. When air rises, it creates an area of low air pressure beneath the rising air, which pulls in air from around. Due to the Coriolis effect, this air being pulled in is deflected right in the northern hemisphere and left in the southern hemisphere, so storms spin anti-clockwise in the northern hemisphere. And I should have said clockwise in the southern hemisphere. Tropical storms form between 5 and 15 degrees north and south of the equator. The water must be over 27 degrees C, and the wind shear must be gentle to avoid damaging the clouds as they form. As water vapor condenses into water in clouds, it releases heat, which makes the air less dense, causing it to rise more, which allows more water to evaporate, become water vapor, and rise. The faster air and water vapor rise, the lower the air pressure becomes and the faster the winds become, as air rushes in from around. The Coriolis effect makes storms spin, which makes the air rush in faster due to rising faster, and winds get stronger. Give yourselves a mark out of 16. If you got 15 or more, fantastic, you've really mastered this. Time to embed learning, so I'm really going to deepen your understanding now through practice. Answer these questions using the understanding you've gained about tropical storms, and then mark your answers in green pen. Make sure you use the keywords shown here. Okay, I'm going to show you the answers now. Mark your answers, and then give yourselves a score out of the total. Make sure you add any corrections in green pen. Question 1. Where are tropical storms found, and why? Make sure you have all the keywords that I have and the facts about, for example, the latitudes and the temperatures. Question 2. Why does the Coriolis effect cause storms to spin? Make sure you have all 4 key points explained in the order that I have, exactly as I have. You don't need, of course, for it to be word to word the same. 3. How does a storm surge happen? Make sure you have both key points as I have. Give yourselves a mark out of the total, and if you got 8 or more, fantastic, you've really understood this. Make sure you add in green pen any corrections or any points that you missed. That's so important for improving your answers in future. Next lesson, we're going to be looking at how we measure the different types of tropical storms and how powerful they are, to help you understand how different strengths of tropical storm, much like different strengths of earthquake, cause different amounts of damage and require different responses. Join me then.